Exclamation everybody, and welcome to TIS-100. Mark this day down. I am playing a puzzle game on the YouTubes. This game is in early access. It is developed by Zachtronics, which are the people that brought us Space Chem and Infinifactory. Ordinarily I don't deal or dabble in puzzle games too much, but given as though this is a programming related puzzle game, I was curious, and it's also relatively cheap as well. I was curious to try it out. I've looked at other programming like puzzle games, and I've found them all sort of lacking greatly, because they tend to really dumb things down to the point where it gets actually frustrating when you know what you're doing. An example is I've been looking every so often. I've been popping into a game called Code Combat to take a look at what they're doing, and I like the idea behind the game, and I like how they sort of simplified some things, but it was incredibly frustrating when I couldn't do things like, hey, I want to write a loop, or some of the more advanced things that make it so that you don't have to type 900,000 things. That said, as you can see on this screen here, I've done two puzzles. I'm going to go back and do them again, the first two puzzles, and so far so good. I kind of like what I'm seeing so far. You can see I did it like 128 cycles and 6 nodes and everything else. I kind of like what I'm seeing so far. It is dumbed down. There is a manual that you have to actually look at. I have a PDF open on another screen here, trying to look at the manual back and forth. This game deals with assembly language. The assembly language in here is not real-world assembly language, so that's my first qualm. It's understandable though, since assembly language is pretty difficult, even for someone who's seasoned. But that said, it is pretty faithful in some cases here. So let's go ahead and start our first puzzle here. Now there's a bit of a story in here as well. The idea here is it's like you're trying to repair this computer. It's like an 80s terminal computer. And you've got a series of nodes here, all of which are processing nodes in this particular case. And along the way you see these things like communication failure, debug. Like if I click on this, it'll actually dump out some text, because there is a little bit of a story that you sort of uncover as you're doing puzzles. Again, I haven't gotten very far on it, so and there's also other secret things apparently along the way, but I don't think I've gotten far enough in to do that. And you can see it's a little bit corrupted too. The idea is that you're trying to fix the corrupted memory space of this computer by writing the code that is missing, that is no longer functional, and you run through it. You're in a debugger here, and this whole screen is a debugger, and then you run through your programs and you try to match the inputs. You take the inputs and match them up with the outputs that are supposed to come out the other side of the fence there, and then once you've done that successfully, then you've completed that challenge, and that node is now or that segment of memory is now restored. So, compute node diagnostic, microcode dump. Find a pen right now, so I'm just going to take notes here. Looks like short-term storage. Got this one at the swap meet today. Fellow won at $450 for it, but I talked him down to $200. Good deal. No idea who makes this thing. Never heard of the TIS series, and the architecture doesn't look like anything I've seen before. Asked the guys, but no joy. Randy has a mystery on his hands. Okay. And because there's a communication failure here, I believe I can't use this as a node to move things around. The idea here, as I said, here's your objectives for this particular puzzle, which is read a value in from in.a, which is up here in this node, and write the value to out.a, which is down here at this node. And then you're actually writing assembly-like language to move this stuff around. You've got a series of registers here. You've got your accumulator. You've got a backup register that you can't write to directly. You have to use a different opcode for that. You've got a null one that doesn't show up. That's always null. And then this is like the last command that ran and whether or not it's idle or is currently processing things. As you write code in here, it'll go through one at a time your instructions, and then it'll loop back to the beginning. So it's an automatic looping node, and you'll see what I mean as I do some stuff here. Here is the inputs I'm getting in in.a, and here's the outputs I'm supposed to match on out.a. Now, since this is the first puzzle, it's a relatively simple one. All I really did, the in and the outputs are all the same all the way down here. So really, I just have to transport things around. So I will say move up. So each node has up to 4 connections. There's up, down, left, and right, and that's how you communicate with the data going into those nodes. So I want to say in this case I want to move up to the left, yeah, and then over here, and I can use Control and the arrow to move to different nodes here. So I'll say, or you can use the mouse if you want to. And I'll say move right down, and then move up, down, and move up, right, and move left, right, and move left, down, and that should be all that we need to do to get this inputs to match these outputs. So we'll hit F5 to run, and as you can see, it's running through the inputs now, and kablamo, test has passed. We did it in 84 cycles. We used 6 nodes in it and 6 instructions. The idea here is that you're sort of judging yourself on how well optimized your code is, and you want to get this as few cycles as possible. You don't have to. It doesn't enforce that as far as I know, but it's one of those things where continuous improvement is one of the goals, and it's also a goal for programmers in the real world. So that's why I kind of like the way this is going here. I like how this game handles things, and of course that program is now saved, and all the data for it is, and I can copy it if I want to and start and modify it, or it seems like each segment here you can have up to 3 programs saved for it. So if you want to swap out different programs, there's also apparently a or at least going to be a virtual sandbox at some point where you can actually just write whatever code you want and just run it as a sandbox thing. There's a little bit of a visual console that you can write to. It's a 4-color console, various things like that. So that's a self-test diagnostic. Signal amplifier, we'll do this one now, create new program. All right, and here we need to read a value from in.a, double it, and then write it to out.a. Okay, 11, 22, 12, blah, 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 blah. Okay, very good. Let's see what this communication node says here. 7/18/1979 continues to baffle. Chatted with Bernie at IBM, and he says it sounds like something they come up with in the USSR, but then why is the manual in English? All right, and I assume that these node failures are here just to make things a little bit more difficult as time goes on. Also, there are different types of nodes, from what I understand from reading the manual here. There's computing nodes like these, and then there's memory storage nodes and various other things. I have not encountered any of them yet. This is the only other thing that I've done. I haven't even done the 3rd challenge yet. As I started playing, I realized, hey, you know what? This is actually not so bad. This is something I can get behind. Normally by now I'd be really frustrated by what I'm seeing, but this one is actually a lot closer to home than most of the other programming games out there, programming puzzle games out there, and it's also, I guess, I can see the power that this will bring to as far as puzzles go and so on and so forth, because you got all these nodes going around, and I can see the potential in there. So, and it's still, early access, so it can change a little bit as time goes on. All right, we want to move left, left, down. Also, I may, there's no music in the game. There's sound, but there's no music in this game. So I may add some of my own music at the, some music that I have around on the hard drive. I might add to it, just so that you have a little something to listen to besides just my increasingly weak voice here. Move up, down, move up, down, and then we want to make sure that we double this. So we're going to say, we're going to say, I think it's just an add command that doubles it, right? So I think it's move up to the accumulator, add, and, or was it add up accumulator? Hang on a second. Trying to figure out all the different instruction sets here. Add source. Value of source is added to the accumulator and result is stored to the accumulator. Okay. All right. So it's, so I moved this to the accumulator. I thought there was a double thing though. I guess that's not, no. Oh, I got it. So add 16. I could have swore that there was something that's like double your fun. Double your money, double your fun, but I guess not. So I just want to double this guy. There's no bit shift things either, which is kind of weird. But anyway, so we'll say add. You can do add accumulator. That's what it is, and you will add the accumulator to itself, which effectively doubles it, and then move accumulator down. And then that should be all that we need to do here. Let's see what happens. Looking good all the way through. Very good. Test passed. Got it in 160 cycles, 4 nodes we used, and 6 instructions. Very good. All right, now, so we got those 2 completed again. Now I get to look at this one, differential converter. Let's see. I have not looked at this one before yet, so I don't know what to expect here. And there's some cycle. This is like the leaderboards that you're seeing here, cycle count statistics and stuff there. All right. Read values from in.A and in.B. Write in.A minus in.B to out.P, which is down here. Write in.B minus in.A to out.N. Okay, so as always, and this is one of the reasons why I like this too, is that it really does. This is the kind of thing that a programmer does in real life, right? They take a problem space and they break it down into smaller problems, and to tackle the smaller problems first, and then the accumulation of all those small problems allows you to tackle the bigger problems. So the first thing we want to do, we want to read from, we know that the values from in.A, so yeah, we want to, basically, it looks like, so all I have to do is subtract those guys, right? And there is a subtraction thing, which will subtract to the accumulator. So really, we don't need to do subtractions until we get to the very last node, I would think. So what I can do right now, let's just take a look at this. Let's go down here. So out.P needs, what does it need? It needs in.A minus in.B. All right, so we got in.A coming down this way, coming down this middle path, and then in.B coming down this one. So what we want is, we want to move up to the accumulator, right? And then we want to sub left from it, because that will be A minus B. And then we want to move accumulator down. right? And then over here, it's basically almost the same thing, except slightly different. We want to move left. Oh, I see the problem here. Okay, hang on a second. This is why I started down here. So we sub left, right? So first things first. First things first. We want to move up to the accumulator, right? We want to save that, right? Then we want to move the accumulator right, because we want in.A to go over there, over to the right. And then we sub the left, right, which is good. Okay, so all that should be good. So then over here, we want to move up to the accumulator. So this is in.B, right, which is our first criteria there. And then we want to move the accumulator to the left. Now, move is not actually a move. Move is a copy, if I remember from the instruction book here, which is how it normally, there is actually a move, I believe. Yeah, there is actually a move assembly language operation on normal Intel processors as well. And it does the same thing. It's just a copy, right? So if I is read from the left, written up port, and then discard. Oh, okay. Yeah, that's for that stuff. Yeah, I believe it just does a copy. So I should still have the value in the accumulator. We'll see in a minute when I do this. So we move that to the left, and then we want to sub left. I did this one wrong. This should be sub right here. Just wondering what I was thinking here. Sub left, and then move the accumulator down, and then all these up here are just basic move things. So move up, down, and move up, down. Same over here. Move up, down, and move up, down. All right, let's see if this works the way that I think it should work. I'm going to step through this one so that we can see it. Actually, what you can do, since this is a debugger, you can actually put breakpoints in here. So I'm going to put a breakpoint here, and put a breakpoint here. You just put an exclamation point in front of it, and that's your breakpoints. So then what I can do is, instead of, if I do a step, right, it's just going to step one at a time, one at a time, one at a time, right? But if I do run, if I put breakpoints in here, when I hit run, I can run through all these guys real fast and then come down to, and then it'll stop at its first breakpoint down here. If I do this right. So there we go. So now these guys are at 19 and 55 has moved down there. Oh, so it is actually doing an actual move, it looks like. Well, wait, no. 1955 are these numbers. Okay, so we've got 26 in here, and we got 10 in here, right? Which is the first two lines here. First two guys in this first line. All right. And we want to move the accumulator right. This may or may not work. So we'll do and we're moving the accumulator left here. So let's do a step. All right. Yes. Okay. So it did just do a copy, which is good. That's all it does. As you can see, these values move down here, but they will sit there. This is like a semi-queue. Well, they'll just sit here and they won't actually go anywhere until they're read. Even though more are being read in, these are just going to move down here and kind of wait, which is nice. So as you can see, 26 went to the right, 10 went to the left, or 26 is available to be read on the right, and 10 is available to be read on the left. So then we do another step here, right? It's not actually stepping the way these guys are not stepping for some reason. I'm not sure why. Oh, you know what? I know what's going on. Yeah, I know what's going on. Never mind. It's I remember reading this in the manual. It's blocking because these guys are waiting for each other. So what we wanted to do, because this guy's waiting for this guy and this guy's waiting for this guy, so it's just stuck in an infinite loop basically, waiting to read stuff. So what I need to do is make this guy take a little bit longer, I suppose. Yeah, I gotta make this guy take a little bit longer, I think. So if I do a no-op here, let's see what happens. Now they're still kind of waiting on each other's stuff, so I can't really do it the way that I wanted to do it. So I'm gonna have to use these other nodes, these other intermediate nodes along the way to do what I wanted to do. Which kind of sucks, actually. Which means we're gonna have to break this up some more, I think. So what that means is, what we're gonna do here is we're gonna move up to the accumulator, and then we're going to let's think here. How would I do that? That doesn't seem like that's going to work so well. I guess we'd have to bring some other nodes into play. That doesn't seem right either. That's very, very strange. Very, very strange. Just kind of curious about this here. Looks like there's some kind of static memory in this thing, encoded something or other. Okay, alright. This is interesting, because it's not working the way that I would expect it to work. What I can do is swap these around. Alright. So move up to the accumulator. We sub with the right, and then move sub with the right, and then move accumulator to the right. Alright, and then that should change the order of operations then so that they aren't dependent on one another, hopefully. Yeah, that should do it, I think. Or not. Or not. Let's do... what is going on there? Let's put a breakpoint here. Let's run to that breakpoint. And what did we get? We got 16. So, let me think here. So I moved A. It's got to go to out P, right? In.A minus in.B to out.P, right? So if I moved up, which is 26 to the accumulator, right? Which then, so that's actually correct. It's just the out.N that's not correct. And why is that not correct? Oh, because I already screwed with the accumulator. That's why it's not correct. Okay. All right. Yeah, that makes sense. So, yeah, because it's going to move 16 over, which is not what I want. Or is it? Wait a minute. 16. Wait a minute here. I'm noticing a pattern. Are you guys noticing a pattern? So out.P is negative and out.N is the negation of it all the way down. Okay, so I don't have to take it so literally. What I can do, instead of doing a subtraction here, right, I just do I think it's negate, neg, right, is arithmetically negated. Okay. So we've moved from the accumulator left, then we move the right to the accumulator, then we negate it, and then we move it down. There we go. This will do it. Oh, I forgot I still have the breakpoint on there. Hang on a second. Let's move that. and try it again. Yeah, it's still stuck on the actual... Alright, so it's waiting for input there. Move accumulator right. That was kind of working before. Oh. Move left accumulator. That's what I wanted to do. There we go. Now it's working. There's more than one way to skin a cat. There we go. So that's the other thing to keep in mind when you're programming. You don't always have to take it literally. Sometimes you just gotta look at what data you need coming out of it. So there we go. 315 cycles I did it in, and 13 instructions. It took a while, but this is... So if you've ever wondered, why does it take so long to do oh, I didn't want to continue editing. I want to return to segment list. Why does it take so long to write code? Well, there you go. That's why it takes so long to write code. This is a good... Why does it take so long to make games? Investigation, if you will. 9/3/1979 found a block of static memory, but it's in a proprietary format that I never saw before. Can't make heads or tails of it. Oh, brother. There's just too many different kinds of machines coming out now, and I like tinkering with them as much as the next guy. But when every Tom, Dick, and Mary implements their own memory address scheme, I think the bomb's going to drop out of the microcomputer market soon. Mark my words. Yeah. Yeah. All right. So in this case, we've got, what do we have here? So read a value from in. Okay. Write 1 to out.g, which is down here. If in is greater than 0. Okay, so we're going to use some of the conditionals now. That's kind of nice. Write 1 to out.e if in equals 0. And write 1 to out.l if in is less than 0. If not true, write 0 instead. If not true, write 0 instead. Okay. So, if not true, write 0 instead. Okay, so if it's 0, write 0. If it's... Wait a minute. Okay. So, yeah, it's not true. Right? So if it's 0, write 0 is what it's saying here. So that matches up. If it's 0, write 0. If it's 0, write 0. Okay, got it. If it's less than 0, out.e... Oh, right. And they put that in there too. So if it's 0, 0 must go to out.g and out.l, but 1 goes to out.e. That's fair game. So basically out.e is always the opposite of out.g, right? Out.g and out. Sometimes it's the same as out.l. Okay. Right. So it's pretty much always different than out.g. It's always the opposite of out.g, I should say. Okay. So, what? All right, we got that stuff. So we've got in up here, right? So we want to read a value from in, and if it's not true, we write 0 instead. If it's not true, write 0 instead. That 0 does not go to... that one little instruction there, throwing me for a loop. So let's read the value first. So we'll move up, down. Whoops, down. And then we want to, let's see how I want to do this. Well, we want to do that again because we're way out in left field here right now. And then we'll move up, right. So now when we're here, I want to say out.g gets 1 if in is greater than 0. So we've got some conditional statements over here. So let's see, we've got jump is, if it's equal to 0, right? The value of AC is 0. What does that do? So transfer execution conditionally. If instruction after a label we execute next to the value is 0. Right, so on and so forth. No op, move, swap, save, add. If the accumulator is 0. Okay, so everything's based on the accumulator. So we'll say move right to the accumulator. All right, and out.g should get 1 if in is greater than 0, right? It should get 1. So we will say is greater than 0. And how does this equal jump? If equal to 0. Jump if not 0, jump if greater than 0, jump if less than 0, or jump unconditionally. Right. So so we'll say jump if greater than 0, so it's JGZ, which is not an opcode in the real world. In the real world, you actually have these set of flags. You have flags that get set automatically for you. You got the 0 flag, the negative flag, and several other things, and then all the jump and conditional things are based upon whether those flags are set or not set. In this case, we don't have those flags. We're just doing sort of a pseudo assembly here. So we'll say jump if greater than 0. I keep holding space or doing capital letters, even though it's already doing capital letters for me here. Jump if greater than 0 to a label. So we'll say right here, and then we'll make a label called right, and we'll say move ACC down, right? So we'll jump greater than 0 to right. Otherwise, we'll come up here now and we'll just say what we just want to do is move the accumulator at that point, because we're just testing the accumulator for stuff. So we'll just say actually we always want to do this, right? So jump greater than 0 to right. Otherwise, okay, and then we'll just say else, right? And then we'll say, what was it? Jump. This really should be JMP, which that's what it is in assembly. Is JMP is an unconditional jump. This unconditional jump in this program is JRO. So unconditionally jump to else, and oh, I'm sorry. It doesn't take labels. That's right. It takes offsets. So I want to do 1. Does that include labels? Because labels aren't instructions, so I would assume it's just instructions that you're skipping. So we'll say jump to jump 2 actually. So we want to jump forward 2. We want to jump past this guy, and then where's that? Right. Jump 2. What it was? Next instruction will be skipped, executing instruction following. Yep, that's what it is. And then we'll say move accumulator right. All right. And then over here we will say move right to accumulator. And actually, I don't even really. Do I need that? Yeah, I do need to jump there so that right doesn't write. If it's, well, we always want to write something though. Want to write, yeah, I'm not doing this right. So writing, we always want to write something. But we want to write 1, and that's not what I'm doing here. Let's revisit this for a second. So jump greater than 0 to right which should be writing 1. So we should be saying move 1 down, right? Otherwise, we want to move 0. Want to move 0 down, right? And then over here we can say move ACC right, just so that it's there and ready to go. And then that makes it a little bit easier to grok what's going on here. So what I'm basically saying is move the values from over here, from what comes, read the values from, whoops, I'm doing the wrong, read the values from the left and move them to the right. So read the value from the left into the accumulator, immediately move it to the right so these guys can do their thing. And if the accumulator is greater than 0, the value in the accumulator is greater than 0, go to this label called right and move the value of 1 to down. Otherwise, does that, not sure how that's going to work. Otherwise you would, in theory, you would jump 2 and that would bring you here. I'm not sure if it's going to just continue on to, it's going to continue on to the next label though. So that's not going to work. That's not going to work at all. It's going to have to be, I wonder if that, this is interesting. Yeah, because it's just going to keep on continuing with this execution down here, so it's going to end up moving both 1 and 0 to down, which is not what I want. I need to put another label here, is what I need, unfortunately, which means, that makes this program, makes this program really, jump to greater than 0 to right. Otherwise, I would have to, yeah, this is a little bit harder than it. This is a little bit harder than it looks at first. So I've got my accumulator set up, and I'm testing to see if it's greater than 0. Right, and I want that to go there. It's greater than 0. I want it to write 1 if it's greater than 0, right? But if it's not, that's what that if not true is. Write 0 instead, right? Okay. So if it's not true, if it's not 1, then I want to do that. So what I could do is there a, I wonder if there's a thing here. JLZ is transfer execution conditionally. Execute next if the value of ACC is negative, if positive, not 0. Jump if 0 negates. Jump if it equals 0, I should say. Which would put me here on the next line. This is why people don't do assembly language anymore, because it creates what's called spaghetti code, where you're jumping all over the place and you're like, how do I figure out what I'm doing here? If I jump forward 1, it's kind of redundant. Actually, I want to jump over to next. Yeah, so this is going to be 4 then, right? Because the next one's going to be move 0 to the accumulator, which is the other case. And then we want to move accumulator down, regardless of what's in there. So what I've basically done is to say, all right, up here, if you're greater, then jump to the greater label, which will run this command, put 1 into the accumulator, and then unconditionally jump over the next instruction and down to the move accumulator to the down. Otherwise, if it's not greater, it'll unconditionally jump 4 ahead, which should put it to 1, 2, 3. Actually, it should be 3, right? I think I had that right the first time. Yeah, it should be 3. So 1, 2, and then 3, which will move 0 to the accumulator, and then we'll move the accumulator to down. I think that will work. All right, so then we need something very similar here. So where you move right to accumulator, move the accumulator right once again. And we want to write 1 to out.e if in is equal to 0, right? So we'd say jump if equal to 0 to equal, and then we'll put JRO 3 here, and we'll say equal, right? And then we'll say move 1 accumulator, JRO 2, it's basically the same as the other one. Move 0 accumulator, move accumulator down. And then over here, it's pretty much the same thing, except slightly different. So move, well, actually we don't need to, well, we'll move right into the accumulator. And then we'll do a, what is this? So out.L gets what? Write 1 to out.L if n is less than 0, or in is less than 0, I should say. So if the accumulator is less than 0, then less JRO 3 again, and then we say less, and then move 1 to the accumulator, and JRO 2, move 0 accumulator, move the accumulator down. I think that might work. Let's try it. No, we're waiting on a read here. Okay, so that's not, I have to restructure the way I'm moving things around. All right, so we're waiting for a read. Why are we waiting for a read? Move accumulator right. Move right accumulator. Move left accumulator. Move accumulator to the right. Why are we waiting for a read? So we got as far as here. Move that to the right. And this guy is not moving that into the accumulator yet. That's kind of strange. What are we waiting on there? Because the -2 is there. That guy on the right hand side is waiting for inputs. Of course. Of course. It's move left accumulator. This guy should be left as well. My left and my rights are all messed up right now. That's why. There we go. There's a program that's running. So far, so good. It only took a little bit of teeth pulling to do it. All right, test passed. We did it in 318 cycles, 6 nodes, and 26 instructions. Excellent. All right, let's do one more here and see what this has in store for me. All right, read values from in.A and in.B. Read a value from in.S. Write in.A when in.S is -1. Write in.B when in.S equals 1. Write in.A plus in.B when in.S is equal to 0. All right, we're getting more complicated. conditionals here. We also have this little debug thing here. January 31st, 1980. I might have an idea of where this TIS-100 machine came from, might have come from. I transcribed the architecture to Fred at Motorola, described the architecture to Fred at Motorola, and he says it sounds like it was designed for signal processing. I got my brain going. Government project maybe, something the CIA cooked up to comb through Soviet radio signals, hush hush, top secret, all that stuff. Maybe could I be in possession of a classified device? Something for spooks? I might have to sit on this one for a spell, I guess is what that says. Okay. So, and we have one out. We've got 3 inputs and 1 output. Right in dot A. So read a value from read values from in dot A and in dot B. Okay. Read a value from in dot S. Right in dot A. Right in dot B. In dot S is 0. Okay. So let's see. We'll move. Move up. Right. And we'll move up left. Get my right and my left correct here. And we'll move up to the accumulator. Then we want to... Alright, so we want to take the value from in dot A when in dot S is -1. Alright, when in dot S is -1, we want that. So what can in dot S be? It can be -1, 1, or 0. So less than 0, 0, or greater than 0, basically. So, right, that's all that in dot S is. Yeah, that's what it looks like. Okay, so we're going to do alright, so we move that to the accumulator. So if in dot S is less than 0, so jump of less than 0 to less, right? Jump if greater than 0 to greater, and otherwise we'll just do a conditional. Well, I can just say jump if equals 0. Is JEZ, is it really? I think it is. Yeah, jump if equal to 0 to equal. All right, and we'll do less here, and we'll say if less, then we want in dot A, which is on our left. So we'll say move left down. If it's greater, we move, that's in dot B, right? So we move right down. And if it's equal, we do in dot A plus in dot B. So we just discard whatever in dot S was. So we'll say move left to the accumulator, and then add right, in dot A plus in dot B, and then move accumulator down, right, and then I need to make sure that I do some unconditional jumps here. So we want to I want to, how many instructions will that be? That's 1, 2, 3, 4. Okay, 4 instructions. Or actually I can just tell it to go back to the beginning. That's probably, yeah, that should really go back to the beginning because we're doing a loop. So it would go back, let's see, 1, 2, 3, 4. So go back 4 then. All right, so we'll say JRO -4 there. And then this one would go back 1, 2, 3, 4, 5, 6. All right. So we'll say JRO -6. 1, 2, 3, 4, 5, 6. It's actually 7, right? This is 1, 2, 3, 4, 5. Yeah, this should be 5. And this should be 1, 2, 3, 4, 5, 6, 7. Yeah. It should be 7. So it's basically in a higher level language if you were in a loop and you said continue, very much. And then down here, this will automatically continue since this is like the catch-all. And then all we gotta do is write those. So then all I have to do is say move up, down, and move up, down. Now let's try it. Nope. Nope. Failure. Failure. Let's see where I went wrong here. Let's put a... Where did I go wrong there? Wait a minute. So I got the first one correct, which was in.A is... Right in.A when... Or I'm sorry, right in.B when in.S equals 1, right? So I got the equals case right. I think maybe I'm not jumping far enough back here. Is that what it is? Let's see. Because all the other ones have these unconditional jumps. So let's do... let's just step through it, because that's right at the beginning here. All right, so we said greater, move right down, and then jump unconditionally -7. So we're back there. Right. Wait a minute. In.B is on a different... Oh, that's... Yeah, why is in.B... Move right down. No, that makes sense, I think. So the accumulator is -1. With less, then move left. Oh. Oh, I see what's going on. Move left down. Do I see what's going on? I think I see what's going on because they're sort of out of sync right now. Move left down. Yeah. I know what's going on. I know what's going on. All right, so what's happening is I need to read this entire row, and instead I'm not reading things in certain cases. Yeah. So what's happening is in the case when things are less or greater or equal for that, well, equal is reading from both, so it's okay. But in the case of when something's less or greater, I'm only reading from either the left or the right. But because I'm doing that, the old value in left is still there, or the old value in right is still there, depending on which one I'm doing. So what I need to do, this is why I kick myself all the time here. So what I need to do is say, so I want to move the left down, but I also want to discard the other value that I'm not going to use. So in this case, in the left case, I want to say move right to nil, which sends it to the nil thing, which says just basically discard it. And then this guy is going to have to be like 1, 2, 3, 4, 5, 6. Yeah, this guy goes up by 1. 6 here. And then similarly here, I want to get rid of the... Oh no. I have a maximum instruction count I can do. Oh, that sucks. That really sucks. Okay. Jump if less. Jump if greater. Jump else. Oh. Wait a minute. Maybe I'm just faking myself out here. Let's just do... let's make this... Let's get rid of this label altogether, which not the coolest thing in the world to do, but I'm going to do it. We'll make this a jump forward, and I'll calculate the number later. So left, right, left, down, nil, and down. And then otherwise move the, what did I have in here? I had moved to the accumulator, what was on the left, right? So I want in.A plus in.B when in.S is 0. So I want move left accumulator, right? And then add right, and then move the accumulator down, and this would be like, so I need the jumps here as well. JRO -2 we'll say, and JRO -2, and then this is really like 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's really 9 back. This guy is 1, 2, 3, 4, 5, 6 back. And then this guy would be 1, 2, 3, 4, 5, 6, 7. 7. Oh, I actually calculated that right. 7 forward. Right. So that would then all fit in there correctly, and then all these go back to just move up right, and then this one's move up left, like that, and move up down, move up down. Okay, let's step through this and see what happens this time. Alright, that was the greater than one. And then less. So that wrote the 21 out. So now we need the 25. Did that? We're kind of far ahead there, aren't we? Or no, I think we're right. I think we're right. There's only one way to find out. Yeah, no, I think we're doing it right. Okay, hang on. This might be correct. Yep. It's looking correct. All right, man. I didn't realize that was a limited space there. Oh, that's gonna get really bad later on. Really bad later on. All right, 280 cycles it took to run. 5 nodes we took up, and 17 instructions. Whew, okay, yeah, it's getting a little bit more difficult, but I'm actually, for a change of pace, this is the first time I've played a puzzle game, and I haven't really felt that frustrated, honestly. I like what I'm seeing so far. I can see it's going to be a brain teaser as we go further on, but yeah, I'm really liking what I'm seeing here. This has been TIS-100 by Zachtronics. It's still in early access on Steam. So by developers who have given you Space Chem and Infinifactory, 2 other puzzle games. If you're into puzzle games, or you're morbidly curious about how hard it is to actually write code, even if it's fake code, you might want to go take a look at this. It's relatively cheap from what I remember. And in fact, I think it was actually like 10% off or something. Don't quote me on that. But that will do it for this look-see at TIS-100. Thanks so much for watching, everybody, and I will see you in the next video.